Hello guys, Revit was here. Today I'll be showing you how to create your own custom oval column, which is created within a family. So please stay tuned. Hey guys, let's get straight into it. So the easiest would be is just to open your Revit, and then we're going to go to new. We're going to say structural template and OK. So I feel this is the easiest way to do this, to edit a already existing column family. So we go to structure, choose your structural column. Just make sure you're on your properties, you choose a concrete column. You just place it anywhere. Now we're going to edit this family. So let's go and edit the family. And then you can see it's currently a rectangular column. So let's just save this first. File, save as family. And we are going to save it as an oval column. So I'm just going to overwrite the previous one that I did. Say yes to save. Now that we've done that, we can start. So let's go to the floor plan. So this is how the column currently looks like. So we want to delete that and create our own column. Before we do that, let's just go to the elevation so you guys can see column is currently 2.5 meters high. So we're going to also make our new extrusion that height. So let's go lower level again for the layout. So I'm going to click on it and just delete it. Then what we want to do is go to create, and we are going to say solid extrusion. Then I'm just going to make the depth here to 500 like we just saw on the elevation. So now we just draw our extrusion. So we have our two vertical lines, and then we're going to say tangent end arc, and we're going to just click once and click on the other side, click here, click on the other side. So now you can see we've actually formed our oval column, but now we want to dimension this radius. So you click on the semicircle and you just click on that dimension button and it gives you a dimension. So now we're going to click on this and we are going to create a parameter. The reason is for this is so that we can create a formula for our oval column. So there you can see, just make sure both of them are set to that parameter. Then just before we continue, let's just change our material here. Click on this associate family parameter and the structural material and say OK. And then we can just say finish. Okay, so there we go. I'm just gonna pull this up and down, or down and up, and then we can just see it a bit better. Now what we want to do is go and copy these reference planes to our edge of our oval column, and we are going to then just dimension it. That would be 750, and we will have two dimensions here just to make that equal. Okay, now we want to create another parameter, but before we do that, this h is not our h anymore because it's only up to that point. So I'm going to edit this parameter and change it to h1, and I want the 750 to become my h. All right, so we will go here to family types, and here you can see the r parameter that we've created and the b and the h that has been created with this family. So let's just go and edit the parameter. Sorry, click on the h, say edit parameter, and we just change it to h1 and say OK. There it's changed. And then we're going to do another new parameter and we just call that h. Okay, so now I'm just going to say OK, and then I'm going to click on this dimension and just give it the parameter name h. There we go. So let's go back to family types. So now we are going to create some formulas to make the h1 a change or adapt to whatever we change the h to. Okay, so before we do that, let's just go and say to calculate b, we will have the radius times 2. That's quite straightforward. Just say apply. Then to calculate h, we are going to say, okay, we are going to take h minus the radius. Just make sure it's a capital letter, it's case sensitive, and then times 2. So to explain this formula, we take this h, which is the full length of this column. Then what we do is we minus the radius, which is from that line to that line, and we times it by 2 because we have the same radius dimension on either side. And then we say apply. Okay, so let's test this. Let's say we want our h to be a meter. Okay, let's rather close it. Just say okay. We're going to change it here so we can see better. So I'm going to change this to a meter. Once I change that, automatically the h1 adapts to what I've changed. So if I change the b to 500, the same will happen. This still remains a meter, but that has become 500 because of the radius that's become bigger, because the b is proportional to r times 2. Okay, so let's just undo that. Now we can go and load this into the project, but before we do that, let's just go to your elevation, any side of the elevation, it does not matter. So if I click on the upper level, we want to make sure that, or rather on this column, we want to make sure that this column is locked to that level. Otherwise, your level of your column won't react the way it should within your project. So to see that, if we move this down, you can see it's not locked. So we've moved it down, we can just move it up and lock it. Let's just go back to our lower level and back to family types. Then we will see that these 3 types of column sizes has already been created within this family that we are editing. So I'm just going to delete the first 2, and then I will be renaming this to the actual column size that we have created, which is 300 by 750, and say okay and apply. Now we only have this one column type. Okay, then we will load it into our project. Just going to overwrite it if the question comes up. Now we can just click on this column, go to the drop down menu and choose oval column. Okay, so let's just change the scale, and then we're going to dimension this. So you can see it's a 300 by 750 column, and we can go and edit this type and just duplicate it and make it maybe a 500 by a meter column. So we can see how adaptive this is. So the B would be 500. You can see how the H1 changes. The H would be a meter, and there it's changed. Okay, then we say apply and okay, and there you can see how it's updated. Then we can just have a view of our 3D. We can see that our column is placed here. We can just change the settings to realistic. Then if we go to our east view, we will see that our column is adaptive towards the levels. Even though we've done a 2.5 meter high column, because we've locked it, it's going to be adaptive to any of the levels that you set within this project. Okay, so there I've created it, guys. It's quite easy and straightforward. It's a good tool to have if you have different sizes of oval columns. So once again, guys, thank you for the support. Please like and subscribe, and I'll see you in the next one. Cheers, guys.